Okay, so today we're going through 3L. Now, in my absence yesterday, I set a video for you guys to watch. See, it has a total of 3 views, which means
I was one of them.
Which means all of you found it really, really easy and have completed it and didn't even need to watch the video. So that's great. Okay, that's going to be my assumption. All right, so that means we're moving on to proof using vector geometry. Now, up here I've put question, from our examples, I've put question 1, question 3 and question 4. Okay, and the reason is when we're doing proofs with vectors, there's 2 ways we can do it. We can do it using a geometric argument, which is what we're going to do here, or we can do it using an algebraic argument, which is what question 2 and 5 are about. Now today we're going to specifically focus on geometric arguments, and then perhaps next week when we're starting to do some revision, we can have a look at the algebraic arguments. I think I might say as well, with regards to the test, okay, so at the moment it's scheduled for Friday next week, Thursday next week, but I'm just going to bump that to Monday, all right, because we've got like 6 people away at Cardon or 7 or something, and I've had a number of people requesting extensions. I'd prefer us just to do it all at the same time. Okay, so that means the test is going to be Monday of week 7. All right. Okay, so let's get into these, and we'll do these few together, and then hopefully we're sort of feeling confident enough to do the ones in the textbook ourselves. They do start off reasonably okay, but they do get quite challenging. Now I have emailed some worked solutions to you, and maybe I'll just talk about how you should look at worked solutions, okay, when it comes to revising or when it comes to even trying to learn something. Okay, you shouldn't, all right, have it open there and you're solving the problem here and you go, I don't know what to do, and you look up and you just copy the first line. And you go, okay, I don't know what to do now, and then you copy the second line, because all you're doing there is just copying it, okay? So what you should do if you're stuck, Nick, and you're looking at some work solutions, Nick, eye contact, is you should read it, try and comprehend it. That means you need to understand it. There's no point in copying it because you're not learning anything. You're not even attempting to understand it. You need to read it, understand it, and keep reading it until you understand it, okay? And then like cover it up and try and replicate it, okay? So that's like what you do back in primary school. It's like look, cover, write, check, isn't it? You know, so you're sort of looking at it, you're comprehending it, you cover it up, and then you can check to see if you're on the right path. That's the best way to use solutions, okay? If you are copying, that is completely useless. It's a waste of time. So I have emailed them through, but probably, we'll see how we go. If I think lots of people are finding it challenging, I might go through quite a few up here with you guys. Anyway, let's get into it. So we have here, what does this question ask us to do? Prove that M is the midpoint of AP. Prove that OM equals half A plus half B. Okay, so we're going to prove that OM is half A plus half B. So if we're going to do that, if we're going to find a vector expression for OM, what we're going to need to do is find vector AB. Okay, let's find that first, vector AB. Now, the important part about this is that these are directional. Okay? So vector AB is the vector from A to B. So that means we're going to need to come up with an expression for it in terms of A and B. That is going to be vector BO plus OA, isn't it? Vector AB is going to be vector BO plus OA. Alright? So if we want to go, sorry, I've written that around the wrong way. If we want to go from A to B, it's going to be vector AO plus OB. Okay? Now in simplest terms, because A has a direction pointing that way, that's vector OA, then vector AO is going to be minus A, and vector OB is still vector B. Okay, so the vector from A to B is minus A plus vector B. All right, remember it's directional. We want to go from here to this point, so we're going here and then here. We're connecting the heads and tails. So that's vector AB. Then we know M is the midpoint of AB. Okay, and what that means is that AM equals half AB. All right, that vector there is half of this vector here. All right, which is half of minus a plus b. So that's minus half a plus half b. Okay, that is vector am, the vector from a to m. And then vector OM, I'll make that open here, vector OM, that vector is going to equal OA plus AM. Okay, remember it's directional. We want to go from O to M. That's going to be vector OA plus the vector of A to M. Now OA is A, and AM is this vector here. That's that process. We use that process to find vector AM. So that's plus, we've got what's going to be take half A plus half B, which is half A plus half B. Okay, so we've demonstrated that vector OM is half A plus half B. Okay, any questions about that one? Might fix that off because I might need some more whiteboard space for this next one. So this is question 3 now, so this is on the subsequent page. Let's define AD as A. Now D is the midpoint of AC, isn't it? So if that's A, it means this is also vector A. And remember, it is directional, it has a direction. And we can define this one as B. And so in that direction, it'll be B as well. Okay, and it doesn't really matter which way we define the direction. Perhaps you might see in a moment that a simpler way would be to point it in the other direction. It's not going to matter. So, firstly, let's come up with an expression for DE, vector DE. All right, that's the vector from D to E. All right, and so what's that going to be? It's going to be minus A plus B. If we go minus A plus B, that's going to take us from point D to E. All right. Similarly, let's come up with an expression for vector CB. All right, so that's the vector from C to B. That's going to be minus 2 lots of A plus 2 lots of B. Okay, and so then what we have, that's 2 times minus A plus B. And so we have vector CB is equal to 2 times vector DE. All right, now because they're equal to one another, these vectors are equal, that means they're parallel, they have the same direction. And we have CB is twice as long as DE. Or another way you could write that is that half of CB equals DE. All right, that the value of this, the size of this length, is half the length of this one. So we've proved the midpoint theorem. We did that in deductive geometry. Here we've done it using vectors. So that's a bit of an easier one. Okay. So let's have a look at the 4th one then. Okay, question 4. We've got AD equals 3 times BC. AD equals 3 times BC. So what we might do here is just to begin with define some vectors. So this can be vector A, which means the vector from D to A is going to be 3A, isn't it? It's 3 times larger. And we need to find some value K such that Mn equals K times A. It has the same direction, but we're saying how much bigger is it? All right. We have Bm and Ma are equal because M is the midpoint of this vector. So we could define this as B This is also B, so we've got B and B, and then we'll just go for C and C as well. And I've said it is about direction, but the direction in which we orientate the vectors doesn't matter so much, okay? As long as we're considering the direction when we're solving the problem. So this is a pretty tricky one. What we're going to do here is we're going to come up with two equations, all right? So the first one might be, all right, if I have vector A plus B, okay, so let's just consider the top half of it. A plus B. Another way I could express that same vector, what is that? That's the vector from C to M. A plus B is the vector from C to M. Another way I could express it is minus C plus KA. All right, you're starting at the same point and you're ending at the same point. It's just an alternative way of expressing it. So let's say that again. We can go A plus B, or we can go minus C plus KA. All right, so that's going to be our first equation. Then we can go, let's come up with an equation describing the relationship in this trapezium. We can go KA plus B, all right, we're going from N to A, KA plus B, okay, from there to there, or we could go minus C plus 3A. Okay, now we're going to mix and match these equations together to solve our answer. So from equation 1, right, what I'm going to do is I'm going to move the C over this side. So let's just consider equation 1. I'm going to move the C over this side. So I'm going to have C plus B, and I'm going to move the A over the other side. So over this side I have minus A plus KA. Because they are like terms, aren't they? They're both A. Nick, wake up. All right, similarly in question in 2, all right, I can again move the C over this side. So we'll have C plus B, and move the KA over this side. So we're going to have 3A take KA. All right, and now from here there's a number of processes we could use, but what we can see is we've got equation 1 and equation 2 are equal to one another because they're both equal to C plus B. All right, the left-hand sides are equal to one another, which means the right-hand sides are also equal to one another. We're going to have minus A plus KA equals 3A take KA. Okay, we're going to go plus KA to both sides, so we'll get 2KA here, that'll cancel over there, and add A to both sides, so we'll get 4A here, and we can divide both sides by 2A, and we'll get A is 2. Okay, so I'll probably stop there, but in the textbook, the questions, they start off reasonably easy and they give you, they guide you on what to do, all right? So with a problem like this, I know in which direction I'm going, all right? But perhaps some advice for you guys is start just finding vectors, okay? And then you're going to see if we can create a relationship between them. Let's go to that class. So let's get into that. Let's give it a crack. Proofs with vectors.